Here we go. La, la. So I will begin with a word of prayer. Heavenly Father, we thank you for this day. I thank you for these students, for the apparent lack of seafarers in this room. Help us to learn more about your creation and help students to ask good questions as they have them. And we just ask that we glorify you wherever we do this day, Lord. In your name I pray, Lord Jesus. Amen. No seafarers. I accused a regular student in my previous section of being a seafarer, but then she told me that she was in the class, so I was...
Oh boy.
Oh well. You win some, you lose some. Any questions?
Any questions?
Yeah, any questions about the homework?
Oh.
Nobody?
Should we go over more examples?
All right, I will work problem 24. So example 1. This is like number 24 from week 12 homework. Here it is. Log base 8 of x plus 3 plus log base 8 of x plus 6 equals to log base 8 of 18. So we're asked to solve this thing. This is similar to problems we've done before, but it's just a little different in that it's got a logarithm on the right-hand side as well, right? So I'll start out by just using properties of logs to collapse the two logs together here.
I have a question.
Yep.
Would you be able to just subtract the log from one side and...
Well, I could, but I don't think that really would help me much, would it? So you're saying, well, that's kind of interesting. You could do that. Log. I guess I could do that. This is not how I would usually do this problem, but since you said it, I'll try it. So this is, log of.
I would rather think that the whole thing equals 0.
18 over x minus x plus 6, right? And then by the one-to-one property for the log, that implies that x plus 3 is equal to 18 over x plus 6, which then gives us that x plus 3 times x plus 6 equals to 18, which gives us x squared plus 9x plus 18 equals to 18, which gives us x squared plus 9x equals to 0, which gives us x times x plus 9 equals to 0. Which gives us either what? X equals to 0 or x equals to minus 9. Yeah. Now, I think there is an easier way to do that. Like I wouldn't have subtracted it to the other side. What I would have done with this problem usually is I would just go straight from here to log of x plus 3 times x plus 6, right? And that would be equal to log base 8 of 18, which then, if I raise both sides to the 8 power, right? Exponentiate both sides base 8, that gives me x plus 3 times x plus 6 equals to 18. So as you can see, whatever path you go down, in the end, it's still the same road that we're on. Let's see here, some would say. So like this, obviously, is the same, right? Now the question is, do I actually have two solutions to this problem? Like I did the math here and I found out x equal to 0 or x equals to minus 9. Let's judge those solutions, right? So x equal to 0, that's okay, because if I plug it back up into the initial equation, I got log of 3, I got log of 6. Those are fine, right? However, x equals 0 is a solution, genuine solution, there it is. X equals minus 9, oh, we're going to have some trouble there. See, because when we look at log base 8 of minus 9 plus 3, what happens? We get log base 8 of minus 6, which does not exist, right? So we should cross this one out. That's not a legit solution. This one is extraneous, right? Extraneous. You remember I talked about extraneous before. I told you that if I was to be a wrapper, I would be extraneous G. My tagline would be, I'm not even in the solution set, right? I mentioned that?
Nope.
I have mentioned this before. Maybe you were missing. But you were in most classes. And after I would be like, I'm not even in the solution set, then of course I would do a mic drop, right? Now here, I don't have a mic, so the best I can do is this. Let's try that out again. Ooh, 2 laughs. Interesting. Oh, still? Okay. Huh. Ooh. Okay, it stops at 5. All right. See, in my other classes, I only get laughed for the first marker drop. I was testing. So for here, I get laughed for 4 marker drops. Although it seems like laughing on the second marker drop leads to laughing on the third marker drop because of the absurdity of laughing for the second one. So it's kind of some kind of feedback cycle there. Inertia, I think. I don't know. Anyway, so yeah, so long story short, we have to check our answers, right? All right. Any other problems you'd like me to work on this week? 12 homework?
Is there any that you think we need to know?
You need to know all of them,
No, but
of course. Well, example 2. I'll do example 2 here. Will be number 30. And so this one, you're supposed to solve for A. And you're given that log of A equals to log of E minus big N times log of X. All right, so we're supposed to solve that for A. And it's multiple choice, right? So they want you to not just solve it, but they want you to simplify it in such a way that you can identify the answer as one of their token answers, right? So the way I would do this one is to try to simplify the expression with the logs before I solve for A. So sometimes that's a good idea. So how would you simplify this? This is what? Log of E minus the log of what? X to the power what? Yeah, x to the power n, right? Because remember, one of the properties of logs is that we can pull multiplication outside to a power inside, right? That's by like log law number 2, as I numbered them most recently. And then we use log law number 3 to get log of E divided by x to the n, right? So log of A equals log of E to the x over n, divided by x over n, x to the n. Now when you just write a plain unadorned log like this, what kind of log is it? It's a what? It's the common log, right? It says log base 10, right? So what can you go from here? We do what? You could convert it to the corresponding exponential form. I really would say you use the one-to-one property of the logarithm. Another way you could look at it is I just raise both sides, exponentiate both sides base 10 like this, 10 to the log, 10 to the log. And since log and the 10 to the, the exponentiation base 10, they're inverse functions, so this just gives me a equal to e over x to the n. And there you go. And that, in fact, is one of my answers. Now, yours will look different, but it's the same in spirit, number 30 in week 12 homework, yeah? So just a couple of final examples here. There's basically two main things you need to be responsible for in terms of logarithmic simplification problems. The one is to collapse. And so let's collapse. And so if I have, say, natural log of, the square root, I don't want that. Natural log of x cubed minus 1/3 natural log of y plus 1/2 natural log of z. And I say collapse. And to be more specific, collapse into single logarithm. That was supposed to be single. It somehow became singe. Single. There we go. How do you do it? Let's see here. So this is really log of x cubed, right? Minus the log of the y, cube root of y, right? Plus the log of the square root of z. Right? Because remember, well, anyway, that's just, you guys remember, y to the 1/3 is cube root of y, and z to the 1/2 is square root of z, so I'm using that. And then I go ahead and collapse. So we've got log of x cubed times the square root of z divided by the cube root of y. And there you go. That's the problem of collapsing a logarithm, right? Combining multiple logarithms into a single logarithm by applying systematically log laws 1, 2, and 3. We can also, sure, go for it.
You know that square root of z would be in the numerator.
Because it's a plus?
Oh, so the fractions are denominators.
Exactly.
So much worse.
Yeah, that's all there is to it. If it's minus, it goes downstairs. If it's plus, it goes upstairs.
Thank you.
That's it. If you'll allow me the upstairs, downstairs terminology. If it's minus, it goes downstairs. If it's plus, it goes upstairs. When we do the log law that I'm referring to is this. Log of, x over y is equal to log x minus log y. And that you can apply that repeatedly if you've got multiple addition and multiple subtractions, Like for example,
Starting from the left.
if I had, log of a minus log of b plus log of c minus log of d, that would simplify to log of a times c over b times d. To give you another example. So that's how it works. And that's just by systematically applying log law 1 and log law 3. Log law it doesn't roll off the tongue quite right, but anyway. Okay, so my next example here will be to, instead of collapse, expand and simplify. All right, so we could face something like natural log of e to the x squared times the square root of y plus z divided by x cubed you know, square root of y squared plus 7 there. That's weird enough. Let's chew on this for a bit. Expand and simplify. Mm-hmm.
Log e to the x squared
Okay.
plus log square root y plus c
Yep.
minus log x squared minus log the square root of y squared plus 7.
That is an excellent starting point. So that's the start, right? Yep. We can simplify more though, right? Because the first thing is the natural log of e to the x squared. But remember, the natural log and the exponential, they're inverse functions, right? So this first thing just drops back down to plain old x squared, right? The first term is literally just x squared. The second term, I can pull a half out, right? That's all I can do. The log of a sum does not simplify. That's it. That's the end of the road for that term. You can't do anything more, okay? The log of x cubed, we can pull the 3 down. 3 log x. And then that y squared plus 7 square rooted, we can pull a half out of that. So minus 1/2 natural log of y squared plus 7. And there you go. That's the end of the road right there.
Would you not be able to do 2 log x as well?
2 log x.
Yeah.
Why?
Take,
Where?
Take the log of the first term.
But there's no log there. It's x squared.
Would you not be able to?
No. I can't. I mean, that is natural log of e to the x squared simplifies to x squared. I don't think there's another way to simplify that. I mean, if you're tempted, like, let me talk about that for a second here. So we have e to the x squared, right? This is not equal to, among other things, e to the x squared. Why? E to the x squared, right, is e to the x times e to the x, yeah? Which is what? That's e to the 2x. E to the 2x is not equal to e to the x squared. I don't know if that's where you're going, but like you can't. What I'm trying to say is you can't pull this 2. You can't just pull this 2 out like that. The reason you can't do it is it's not everything raised to the 2 power there. It would have to be, you have to have something like natural log of stuff raised to the 2 power in order to do 2 times the natural log of the stuff. So if the stuff is not actually raised to the 2 power, you can't pull the 2 out. It might look to you at first glance like there's everything raised to the 2 power there, but that's, just an unfortunate.
What I meant is
Poss-
that there's
mhm.
a simplification right there. When the natural log of x cubed, can you not also make that into a log?
I mean, you could, but I think that would not be as simple. If you want to make it into a log, you got to go back where you started. That's what it looks like in terms of a log. I mean, if you want me to, I could be goofier. I can do stuff like, oh, well, x squared, it's obviously log base pi of pi to the x squared. We should write it like that. That would be more simple. But you should reject that, as it's clearly the comment of a silly person, right? Okay, so that's it for week 12. On to week 13. So what comes after week 13? What's that? The quiz 3 would be correct. See, the incorrect thing is that week 13 is due after Thanksgiving break. That's where you're wrong. Okay, so I will cover the material in week 13 starting now today, and of course next week, right? I'm going to do my level best to have covered all of the core of the material by Wednesday so that if you end up missing Friday, it's not the end of the world. Because some of you are going to miss it whether I like you to or not, and I understand. But I do plan to meet Friday as far as I know. I'm not like planning on skipping or anything like that. But again, I'm trying to finish the core of the material by Wednesday if I can. We'll do more examples on Friday probably, all right? So what's left in the course, so the larger point is week 13, this is the last homework. This is it. It's the end of the road. That's it. So once you understand that and everything that came before it, you're ready for the final. Yeah? So this homework covers circles, applications of exponentials and logs, so like word problems, and systems of equations, and solving nonlinear systems of equations. I think that's pretty much it. So there's a fair amount in week 13 homework. We've got a lot to do, but that's kind of it. So we'll start with circles. Now circles, this is section 2.2. Circles and graphs. So this is really, it's been a little bit since we were in chapter 2, right? So why did I push this back all the way to this part of the course? The reason is this builds a natural review of one of my favorite topics, which I think most of you are good on now, but we'll see how it goes. So the first thing I need to talk about is the distance formula, right? Suppose I have a point x naught, y naught, right? And then I got another point over here, like x comma y, right? What's the distance between those 2 points in terms of a formula involving the coordinates here? So what's the length of this blue line? What's this distance? I can do what? I can look at like the triangle here, right? Think about this triangle. I can talk about the change in x, right? Which we usually call like the run, right? So that would be x minus x naught. And I can talk about the rise over here, the change in y, that would be y minus y naught, right? This is a right triangle, so the Pythagorean theorem says that the distance squared, right, is equal to delta x squared plus delta y squared, yeah? So in particular, we have the formula for the distance formula. The distance from x naught, from x comma y to x naught y naught is equal to the square root of x minus x naught squared plus y minus y naught squared, right? So this is the distance formula. You know it. You love it. Excuse me, you forgot it. I don't know if you love it or not, but this is the distance formula, right? What's the circle? So definition, a circle of radius r greater than 0, centered at x naught, y naught, is the collection of all points x comma y, distance r from the center, right? And so what that means is we could say this: the circle of radius r, it's really the circle of radius r centered at the point x naught, y naught. Here's my clumsy notation for a circle of radius r centered at x naught, y naught. It's the collection, it's all points x comma y, such that the following condition is met: x minus x naught squared plus y minus y naught squared equals to r squared. In other words, this right here is the equation which defines the circle centered at x naught, y naught with radius r. Is good? Is good. Good. Let's work some problems. Now that we got this definition in front of us, I'll start out with a couple of geometric problems, and then we'll do a couple algebraic problems. So let's start with the geometry. I'll start with one where I draw you a picture of the circle and I ask you to find its equation. Here's the circle. So the center, I don't know, looks like maybe 3, 4. There's its center. Example, what was this, 5, 6? I can't remember. It's 5, right?
Yeah.
So find the equation of the circle. Them's your instructions. So what should I do? By the way, the top hat's over here.
Which you measure from 0, 0.
Ah, from 0, 0. So it looks like I was careful to make sure you could see that the circle goes through the origin, right? So that means that we can measure the radius by looking at this distance right here, right? So what's r equal to? Square root of what? How do I find how far the point 3, 4 is from the origin?
3 minus, I don't know what it is.
Hmm.
Maybe I'm just doing 1 r. It's just x, right?
Mm-hmm. I guess I mean, if you want me to, I can just use the formula over here, right? I mean, it's 3 minus 0 squared, right? Plus 4 minus 0 squared. Of course, writing the minus 0 does seem kind of silly, but logically, it's just the application of the distance formula in the case that one of the points is the origin, right? And, you know, maybe if I even hadn't had this discussion with you, many of you would have told me this answer anyway, because you would have thought about this triangle here, right? This triangle has a leg of 3 and a leg of 4. So, of course, the hypotenuse of the triangle, it's a right triangle, right? Pythagorean theorem applies, and you got yourself a square root of 9 plus 16. Ooh, man, things work out nice for you guys. 5. So apparently the radius of this circle here is 5. What's the equation? So we got what? We got x minus 3 quantity squared plus y minus 4 quantity squared equals to what? 5 squared, otherwise known as 25. So there you go. That is the equation of the circle that we desired. So
How do we know which one uses x and which one uses x?
which one is x and which one is y?
No, like the x was supposed to be 0. Like in the equation.
Oh, so here x comma y is a variable point.
Yeah, no. the
So-
next one, where it's like x minus x with the 0 squared.
X naught.
How do I know what is x naught, y naught?
No, no. How do you know which x you're using as x?
Oh, but x is a variable here. It's not. I'm not using any x. I mean, this is x is ranges over the whole circle.
No, I know. So on example 5, when you plugged it into R equals 3 minus 0,
Yeah.
how did you know you were going to use 3?
Oh, well, because Federico,
Frederico.
what's happened to me?
Francisco.
Francisco. Oh no, what's happened?
Come on, man.
Hey, it's consistent for my theme for the day. I had a girl ask me in the earlier section what her name was. I was like, oh, I don't know. And then it took me like 3 minutes to guess it. I never guessed it, actually. She finally admitted her name was Kendall. And in my defense, that's not a name you're going to guess. If you either know it and you remember it or you don't, right? Like, that's not like a list on my list of girl names that I just like randomly, go through. So I will refer to you now as number 1. There you go. You can be number 1. I need to give people numbers, that way I can remember them. I do know who you are. I'm sorry, I forgot your name. But all right. So we've established I can't sell things. Let's go on. So does that answer your question? It's because he told me that the origin is on the graph. So that was it.
Is the origin always?
Is the origin always on the graph of the circle? No. Circles don't have to go through the origin. Certainly not.
So at that point, you were putting in like the x naughts and plugging it into the equation. Like you put the origin into the
I wouldn't say that. I would say that I was just calculating the distance from here to here. That's what this is.
She wants to know which one is x naught and
Well,
which one is x.
The center is the x naught comma y naught. That's the center of the circle. It's not on the circle, right? If you plug in x naught comma y, if you put x equals to x naught, y equals to y naught, what happens? You get 0. But I mean, because the distance from x naught comma y naught to itself is 0. So of course the center of the circle doesn't satisfy the equation of the circle. Indeed, the center of the circle is not on the circle, right?
So you use the point of 3/4 for the middle.
What's that?
And x would be 3, x naught would be 3, and y naught would be 4. And for the other x would be 0, and the other y would be 0.
You could think of that, I suppose, but sure. I think I see what you're saying. You're just saying we plug 0, 0 into the equation and it gives us.
Yeah, I was, because like in another example, like say like it wasn't 0, 0. It doesn't matter which order you put the pairs.
Let's see if we can come to an understanding of your question with another example then. How about this? So how about this? So this point maybe is, I don't know, -3, -2, all right? And then there's another point on the circle diametrically opposed to it. Over here, let's say it's at 5, comma 6. And when I say diametrically opposed, what I'm talking about is that these 2 points lie on a diameter of the circle. What's a diameter of the circle? What does that mean?
The line through the middle?
Line through the middle, right. So suppose you're given that this is a diameter. A diameter is a line through line segment, right? Through the center of the circle. You could say it this, it's a chord which passes through the center of the circle, I suppose. So the center of the circle is here somewhere, right? How do you find the center of this circle?
By 2.
Divide by 2? Divide what by 2? I mean, that fuzzy idea is the right idea, but what do we call the middle of a line segment? It's called the what? I mean, we want the midpoint of the diameter, right?
It's the radius.
The center is the midpoint of the diameter, right? That should be geometrically clear. The center of the circle is midpoint.
But it seems like the halfway point between your x's or your y's.
Yeah. And so, like, fun fact, if you want to find the midpoint of 2 points, like midpoint of, say, point P and Q, what you do is you just add the points and divide by 2.
So it's the average.
Yeah, you take the average of both the x and the y. So midpoint, the center, was the midpoint, right? Which we can basically just do this, -3, comma -2, plus 5, comma 6, divide all that by 2. It's going to give us the midpoint. So when I add 5 and -3, I get what? I get 2. If I add -2 and 6, I get 4. I've got to divide that all by 2. What that means is 2 over 2, comma 4 over 2. That's how we divide a point. And anyway, so that gives me 1, 2. So I'm not disagreeing. One of you said you take the average of the x's and the average of the y's to find the midpoint. You're absolutely right. I'm just packaging that formula in terms of adding points and dividing a point by 2. We're not disagreeing. So 1 is the average of the x's, 2 is the average of the y's in the diameter, right? Aha, so the midpoint is 1, comma 2. What was the whole question here? The question again here was to find the equation of the circle, right? All the information I gave you at the starting was the diameter, right? That was it. So, okay, so now we found the center. What's the radius? See, I would rather that we thought geometrically and tried to find the distance from the center to, I mean, I might be agreeing with you, but I would say use the distance formula. Is that what you mean? Yeah. Okay. Because I'm not sure whether you're talking about this equation or that one, but it's fine. Let me not confuse the matter. So which point do you want to use?
The center point and either point.
It's gonna make.
Matter.
It doesn't matter. That's right. So which one?
5.
5, 6. Okay. So you want to calculate r like here, right? This distance. So we do the square root of 5 minus 1, right? Plus what? 6 minus 2, which gives us what? 4 squared. Oh, they're both 16, aren't they? Square root of 32, yeah? Resist the urge that you have to simplify that. It's irrelevant, right? What's the equation of the circle then? We have x. See, now we know the center, we know the radius. We can write down the equation, right? So it's x minus 1, right? Plus y minus 2. Square it equal to what? But remember, it's r equal to r squared, right? R squared. So we have to square it. Oh, man. 32, yeah. Thank you. There we go. Oh, yowzers. Did that answer your question? I don't know. I mean, here you have choices, right? To calculate the r. You could either go one side of the diameter or the other. The other thing you could do is you could actually calculate the length of the diameter, right? And divide by 2, that would be the radius.
X0 is just the midpoint.
Yes.
That answers my question.
Aha. The x0, comma y0 is the center of the circle. Yes. Maybe these examples will help as well. So this, yep.
Would you be able to calculate the example 5 if you didn't take the origin, but x1 and y1?
Well, I actually have to give you another point on the circle, though.
You would.
If I don't give you the origin, I have to give you some point. I mean, if I just tell you you've got a circle and its center is 3, 4, that definitely doesn't satisfy, that doesn't tell you what circle it is, see, because that's a circle with center 3, 4. This is a circle with center 3, 4. This is a circle with 3, 4. This is a circle with center 3, 4. This is a circle with center 3, 4. This is a circle with center 3. I mean, we could be here all day. there's infinitely many circles with the center 3, 4, but there's only one that goes through the origin. Now, the itch you're starting to scratch is the question of how do you fix a circle, right? I mean, if I give you 2 points, that tells you a line, right? As long as those 2 points are distinct. How many points does it take to fix a circle? I don't know. My guess. Probably not 2, because I think if you just had 2 points, you could think of many points, many circles through 2 points, right? If you thought about it. Like here's 2 points, right? Obviously I can make those I can find the circle that's like this, right? But can you guys think of another circle that I could put through those 2 points? How about like this? And if you see that, then you can see this. I mean, obviously 2 points do not fix a circle. Whoa, how did example 5 work? Is the point in the center, is that a point on the circle? It's not, right? So don't buy into my propaganda. That's not at all the same as this. That center point is special. It's not even on the circle, right? It defines the circle in some sense. So if you're given the center point and 1 point on the circle, that fixes the circle. But I think we need 3 points to fix a circle. I think if I have 3 points, I probably can find a circle. But I also think that problem might be too hard for college algebra. Hey, you guys ask questions which make me talk about stuff that's not on the quiz or test, which is fun for me, but maybe not helpful for the students who are suffering in here. I mean, you're all suffering. The students who are struggling is what I meant to say, right? The struggle is real. The suffering is universal. Let's see here. All right, so come on, go away. Go away. Skedaddle. What's that?
Does the formula work by basically showing you all the points that would not be the circle to an extent? Because like everything you said between, obviously like 0, 0, and 3, 4, and example 5, don't hit that line.
Yeah.
Does the formula basically show you by pointing out the radius everything that isn't part of the circle, and that kind of shows you what is?
I mean, the circle is the set of all points equal distant from the center point, right?
Yeah.
So if the distance is not equal to whatever this distance is, which was 5, then it's not on the circle. Like if you're not distance 5 from the point 3, 4, you're not on the circle. So like some easy points you could get on the circle. If I go 5 units over, I'm where? 8, 8, 4, right? If I go 5 units this way, I'm -2, 4, right? The north pole of the circle, if you will, up here, 5 units up, right? 3, 9. The point down here, 5 units down, 3 minus 1, yeah. Other points I have to work harder on because, the distance being equal to 5 when you have a triangle, then I have to actually kind of think about it and stuff, but does this answer your?
Yeah.
Okay. I'm not sure that was a question as much as it was an observation, and I approve. Let's see here, example 7. How about this? X plus 2 quantity squared plus y minus 7 quantity squared equals 242. Find me the center and the radius of this circle.
You've already found the answer to life, the universe, and everything.
Yes. So where is the center then? 2, -7 would be exactly wrong. But it's wrong in a good way. I mean, what is it?
-2, 7.
-2, 7, yeah. So remember, it's this issue again that we've run up with all our other formulas, right? We have to think about the minus, right? Think about the minus. Whatever the center is, when you plug the center into the formula, you should get 0 from the left-hand side, right? Which means, again, just to beat a dead horse, the center is not on the circle, right? The center is not on the circle because when you plug the center into the equation, you get 0 from the left-hand side, and 0 is not equal to 42. It's not on the circle, right? It is the center of the circle. Nevertheless, it halfway defines the circle, right?
So question, how can the center of the circle not be on the circle?
By definition.
But why?
Because no point is distance 5. No point is distance r away from itself. The very definition of distance is that every point is distance 0 from that point. No matter how abstract your concept of distance is, the distance function has this property. Radius is what? Square root of 42. There you go. See, that wasn't bad, was it? So, could this be a question on like quiz 3, test 3? It definitely can be, right? This is an easy question if you have digested the meaning of that equation, right? It's a very hard question if you still are kind of like not quite catching what the equation means. So, okay. Now, I advertised all of this as a means to review material from earlier in the course. That hasn't yet been obvious why that's the case. Let's look at something. So, I have x squared plus 10x plus y squared minus, 7y equals to 100. Find center and radius of the circle. Group the first, what do you mean group the first two? And common what? Factor an x out? Ooh. But how would that get me close to this pattern over here? I mean, how would that make it look? Because I want it to look like this, right? This is the equation of a circle. My target is what? My target is this. X minus x naught squared, right? Plus y minus y naught squared equals to r squared. I want to massage the equation I'm given until it looks like that. Because then I can do pattern matching and answer the question, right? There was no massage needed for the previous problem. It was already in the right format, so we just pattern matched and we're done, right? So how do I make it such? Make it so. I will do it. Here we go. So these first two, I will repackage as x plus 5 quantity squared minus 25. Behold, I have completed the square. Oh no, yes. And then, guess what? I will complete the square a second time. And then plus, you don't like this? Maybe it doesn't like you. Let's see here. No, sorry. my friend Somber Paul used to say, somebody'd be like, I hate the rain, and he'd be like, maybe the rain hates you. It's like, thank you, Paul. I think that's from some show somewhere. I don't know. But anyway, and then I have to subtract the square, right? So I have to subtract 49 over 4. And that's all equal to? 100, right? And then what? So then our quest is to make it look like that. So I've got 125 plus 49 over 4, yeah? Also known as 500 plus 49 over 4. What'd I do? Okay. I'm inclined to believe you. Let's see, 549 over 4. Okay, so what's the center? What's the radius? Negative 5, 7 over 2. See, very good. You have corrected. And what's the radius? Right, the square root of 549 over 4. There you go. Which, of course, we could simplify, but I'm just going to leave it like that. Yeah? Not usually. I mean, I might ask for the decimal. Aw, man. How'd you guys... I got through three more problems in the other section. What have you guys done to me?
We asked questions.
Hey, while we're here, how would you find the midpoint of 3 numbers, like 3 points? Like imagine you had 3 markers and they were like, you know, somehow connected by weightless rods, and you wanted to find the balance point in the middle. How would you find it?
You figure it out next class.
You add the points. You add the coordinates of all 3 points and divide by 3. Like this continues. If you had multiple points, you just add all the points together and divide by the number of points. It gives you their center mass.
Sounds like a big deal.
Yeah.
I think you'd be more worried about the weightless rods than
Well, the weightless rods are expensive. It's true.